On a quiet piece of land in the Florida Panhandle, surrounded by pine trees, old fencing, and a weathered tool shed, a homesteader stood staring at something most people would have ignored completely. It was an old electric water heater tank lying in the grass beside a pile of discarded lumber. Rust covered the outer shell, insulation hung loose from the sides, and the entire thing looked destined for the scrapyard. Most people would have hauled it away as junk. He looked at it differently. Electric bills had been rising for months. Running hot water in his small cabin had become one of the most expensive parts of daily life. Every shower, every load of dishes, every cold morning came with a hidden cost. Propane prices climbed. Grid outages became more common during storms. And the idea of depending entirely on utility companies no longer felt secure. So instead of buying another expensive appliance, he started researching older methods people once used long before modern electric systems dominated every home. That search led him to one simple concept: a box, a tank, a pane of glass, and sunlight. At first, the idea sounded almost too simple to work. Heat water using nothing but the sun? No pumps, no solar panels, no electronics, no moving parts? Most online discussions treated it like an outdated experiment from another era. But the physics made sense. Sunlight enters through glazing. A black surface absorbs heat. The enclosure traps that warmth like a greenhouse. Simple. Next morning, he decided to test it himself. He stripped the old tank down in his driveway. The outer metal shell came off first. Beneath it sat damp fiberglass insulation packed around the steel tank. Wearing gloves, long sleeves, and a respirator, he removed every layer carefully until only the bare metal cylinder remained. The tank itself was surprisingly solid. No major rust holes, no cracked fittings, no leaking seams, just years of neglect hiding something still useful. He flushed sediment from inside the tank until cloudy mineral-filled water finally ran clear. Then he wire-brushed the exterior and coated the entire surface with high-temperature matte black paint. Under the afternoon sun, the steel transformed from faded gray into a dark, heat-absorbing surface designed to collect every bit of solar energy possible. Then came the enclosure. Using pressure-treated 2x4 lumber and leftover plywood sheets, he built a rectangular insulated box large enough to hold the tank horizontally. Inside the walls, he installed foil-faced polyeso cyanurate insulation board to trap heat and reflect infrared radiation back toward the tank. The front remained open. That opening would become the collector face. Of purchasing expensive specialty glass, he salvaged a sliding glass door panel from a remodeling project nearby. It fit almost perfectly. A thick bead of high-temperature silicone sealed the edges, creating an airtight, transparent barrier between the tank and the outside air. By the end of the weekend, the strange-looking structure sat on a simple wooden stand facing south toward the open sky. Neighbors laughed at it. From a distance, it looked more like a homemade storage chest than a water heater. One neighbor joked that it resembled a breadbox sitting in the yard. The name stayed: breadbox heater. Monday morning arrived with clear skies and cool temperatures around 55 degrees Fahrenheit. Before sunrise, he filled the tank with fresh water and checked the thermometer attached near the outlet pipe. 55 gauss-df.cold. Exactly what came from the ground. The waited. By late morning, sunlight poured through the glass panel. The black tank surface inside began absorbing heat rapidly. The air trapped between the glazing and the tank warmed dramatically. Unlike open air, the heat struggled to escape. The greenhouse effect took over. At noon, the temperature had climbed past 100 degrees. By 2:00 p.m., it crossed 130 degree cracks. At 4:00 p.m., steam lightly fogged the inside corners of the glazing. The thermometer read 158 degrees Fahrenheit. Electricity had been used. No propane burned. No pumps circulated anything. The system had silently turned sunlight into stored thermal energy, using nothing more than basic materials and physics understood for generations. That single afternoon changed everything. Suddenly, the project stopped feeling like an experiment. It became infrastructure. Within days, he connected the breadbox heater to his cabin's existing water heater. Instead of heating freezing cold groundwater from scratch, the electric heater now received preheated water already warmed by the sun. The difference appeared almost immediately on the utility bill. The electric heater activated less often. On sunny days, it barely turned on at all. Long afternoon showers no longer carried the same sense of guilt about wasted energy. Dishwashing became cheaper. Laundry became cheaper. And, unlike complicated solar panel systems, there were almost no components that could fail. No batteries, no inverters, no charge controllers, no motors, no software updates, just sunlight heating water. But the system was not perfect. A few weeks later, the first real limitation arrived: clouds. Several overcast days rolled through the region, reducing solar gain dramatically. Water temperatures still increased slightly, but not enough for comfortable showers by evening. Overnight heat loss also became noticeable. By morning, the tank temperature had dropped significantly, so he improved the design. He added an insulated exterior lid that could be closed after sunset to reduce nighttime heat loss. He insulated every exposed pipe leading to and from the system. He upgraded several fittings and installed a thermostatic mixing valve to prevent accidental scalding during extremely hot afternoons. Each adjustment improved efficiency. Then winter arrived. One cold front pushed nighttime temperatures close to freezing. That became another lesson. Pipes freeze faster than tanks. Before the temperature dropped too far, he drained the system completely using a simple bypass valve arrangement. 10 minutes later, the collector sat empty and safe while the conventional heater handled the winter load. By spring, the system was running again. Over time, other people began noticing. Friends visiting the property asked questions. Neighbors who once laughed now wanted to know how hot the water actually became. Some assumed hidden electric heating elements must be inside the box somewhere. There weren't, just sunlight. One retired plumber studied the setup carefully and admitted something surprising. The funny part, he said, is this isn't even new technology. And he was right. Solar water heating has existed for over a century. Entire countries use variations of it at massive scale. In Israel, solar water heaters became standard on most homes decades ago. Commercial manufacturers have sold certified batch heaters since the 1970s. The science was never secret. The reason most people ignored it had less to do with physics and more to do with modern convenience. People had become accustomed to invisible energy. Flip a switch, turn a knob, hot water appears. Very few stop to think about how much energy water heating actually consumes. A typical household may use thousands of kilowatt hours every year simply heating water for showers, dishes, and laundry. Yet much of that energy can be offset using direct sunlight far more efficiently than many realize. Solar thermal systems convert sunlight into usable heat with efficiencies reaching 60% to 80%. That is dramatically higher than standard photovoltaic solar panels converting sunlight into electricity. For heating water specifically, simple thermal systems often outperform far more expensive technologies. Still, the breadbox heater demanded a different mindset. Timing mattered. Hot water availability followed sunlight patterns rather than unlimited on-demand consumption. Heavy usage worked best during late afternoon when the tank reached peak temperature. Morning showers were cooler after overnight heat loss. Consecutive long showers could deplete most of the stored heat in a single evening. The system rewarded awareness instead of excess. And strangely, that became part of the appeal. The homesteader found himself paying more attention to weather, sunlight, and energy use in daily life. Cloudy mornings meant conserving hot water. Bright, clear afternoons meant abundant free heat arriving silently from the sky. Energy stopped feeling abstract. It became visible. Months later, he calculated the numbers carefully. The salvaged system had cost under $150 to build initially. Even after upgrades and plumbing improvements, total costs remained far below a conventional solar installation. Utility savings continued month after month. At the current rate, the project would pay for itself completely within a couple of years. After that, the sunlight was essentially free. Maintenance proved minimal. Once a year, he cleaned the glass surface to remove pollen and dust. Every few years, he inspected the anode rod inside the tank and replaced worn seals where necessary. No fuel deliveries, no complicated servicing, no dependence on unstable energy prices. Just a black tank inside an insulated box, quietly collecting heat every sunny day. Over time, the project became more than a way to save money. It represented independence. Not total independence from modern systems, but partial freedom from constant consumption and recurring bills. A reminder that some of the most effective technologies are not always the newest or most complicated. Sometimes efficiency looks surprisingly simple. A tank, a wooden box, a pane of glass, and sunlight crossing the sky exactly as it has for billions of years. The physics never changed, only the way people choose to use it.